Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Hydrolysis of gem-trihalides, trihalomethyl compounds, under alkaline conditions. Moving on to the next step. Identify benzotrichloride. Benzotrichloride is C6H5CCl3, phenyltrichloromethane, where the CCl3 group is attached to the benzene ring. Moving on to the next step. Reaction with milk of lime, CaO, to an alkaline aqueous suspension. The CCl3 group undergoes hydrolysis under alkaline conditions. Each CCl bond is successively hydrolyzed. And for the final step. Mechanism of hydrolysis. The CCl3 group first hydrolyzes to give CaO3, a geminal triol, which is unstable and spontaneously loses to water molecules to form the carboxylic acid C6H5CCl3 plus 3H2O C6H5C, 3 plus 3H close C6H5Cu plus 2H2O. The overall reaction gives benzoic acid, C6H5Cu, and calcium chloride as the inorganic byproduct. Why other options fail? A. Benzyl, benzaldehyde, C6H5ChO. This would require a CHCl2 group, benzyl chloride, not CCl3, C. Benzyl alcohol, C6H5CH2. This would require a CH2Cl group, benzyl chloride, not CCl3, D. Phenol, C6H5. This would require direct substitution on the ring, which does not occur under these conditions. Therefore, the correct answer is B. Therefore, the correct answer is option B.